Welcome to a Learn to Learn Science video. Today we're focusing on maximum mass. So calculate the maximum mass of iron that can be produced from 320 tons of iron oxide, highlighting the parts of the equation we need. We need the iron oxide and the iron. Step 1 is find the MR of the whole compound that we are starting with. So we are starting with iron oxide. To work out the relative formula mass, we need to recognize that there are 2 atoms of iron. We are going to then do 2 times 56, which is our AR from the question, and there is 3 atoms of oxygen, so 3 times 16. Add those together and we get our MR of 160. Step 2 is finding the mass of the specific part the question is after. So we are after the maximum mass of iron. Therefore, from our balanced equation, we have 2Fe. So we are going to multiply our AR of iron by 2, which is going to give us 112. Part 3 is calculating the scale factor. To do this, we are going to deal with the 2 knowns that we have from the question. So we know that we have 320 tons of iron oxide and we know that MR is 160. So we are going to do mass divided by MR, which gives us 320 tons divided by 160, which gives us 2, meaning our scale factor is 2. Now we are going to take that 2 from part 3 and combine it with 112 from part 2 so that we can get our mass, which we are then going to do 112 times 2 to get our final answer of 224 tons. Note my units haven't been touched. I have just wrote tons because I have kept it in that way from the question. Question number 2 is calculate the maximum mass of pure copper that can be extracted from 160 grams of copper oxide. Highlighting the parts of our equation we need copper oxide and we need copper. We do not need to touch the oxygen. Step 1 is finding the MR of our whole compound. So we are finding our compound copper oxide. Note that from my balanced equation, I have 2 copper oxides. I also have 2 coppers. That means I have a 2:2 ratio, which if you wish, you can simplify before you even begin as a 1:1 ratio. You will get the same answer either way, but I am going to keep mine as a 2:2 ratio just for when it doesn't quite work out. Is a 2:2 or a 1:1? I know what I'm doing still. So I'm going to do 1 times 64, which is our AR of copper, plus 1 times 16, which is our AR of oxygen. Add them together and I will get 80. But of course, I'm keeping my 2:2 ratio, so I'm going to multiply 80 by 2, which gives us our total MR of 160. Part 2 is find the mass of the specific part of the question. We are asked for the maximum mass of pure copper. So keeping with that 2:2 ratio, we have 2 Cu for our copper. So I am going to do 2 times copper's AR, which is 64, which will give us our total of 128. Part 3, again, you have to think what are our 2 knowns. I must use something from the question here. I have 160 grams of copper as my mass. I've previously worked out my MR of copper oxide, so I have 160 divided by 160. Mass divided by our MR is going to give us our moles. Also, in this question, I do refer to it as scale factor, meaning our scale factor is 1. Finally, I'm going to multiply the part by our scale factor. So we've previously worked out the MR of copper in our balanced equation is 128. I'm going to times it by the scale factor. For all our purposes, I'm still going to write it even though it's just a times 1, and that gives us 128 grams. Now it's over to you to calculate the maximum mass of aluminium that can be obtained from 510 grams of aluminium oxide. I will leave it over to you. Come back and check your answer. So we are going to calculate the maximum mass of aluminium that can be obtained from 510 kilograms of aluminium oxide. Start off by highlighting what it is we need from our balanced equation, which is aluminium oxide and aluminium. Now I have taken away the 4 steps this time because obviously you do not get them in an exam. So question number 1 is our MR of aluminium oxide. Part 1 of our question. We have 2 aluminium, so I'm timesing it by 27, and we have 3 oxygens, so I'm timesing 3 by 16. That is going to give me a total of 102. But of course, we have a 2 in front of that entire molecule, so I need to bear that in mind and multiply everything up, which gives us our MR of 204. Step 2 is to work out our MR of the maximum mass of what we want. So which in our case is aluminium, which is 4Al, which means I am going to times 4 by our AR of 27, and that is going to give me 108. To work out my scale factor, I'm then going to do mass divided by MR, unknown from the questions and from what we've already worked out. We know 2 bits of information about the aluminium oxide, which is why we are going to do this one in step 3. So 510 kilograms, divide that by 204 gives us 2.5. So that means our scale factor is 2.5, which is what we are going to use in part 4 to scale up aluminium. Now we have worked out in part 2 that our aluminium is 108 for its MR. We are going to times that by its scale factor of 2.5 to give us our mass, which is 270 kilograms. Note I haven't touched the units, I'm just using the same ones in the question. Thank you for watching. Please subscribe, and if I can help in any way, please let me know.